Hi all the students, today we are going to study time division multiplexing. So what is time division multiplexing? Basically a third kind of multiplexing technique wherein you are dividing the time among various senders, right? So time division multiplexing is a digital procedure. So when I say it is a digital procedure, what does that mean? It means that it can be handled entirely by digital electronics. So, and for that reason, because everything is being consumed by digital electronics these days. Whatever data we are sending through digital electronics. So for this simple reason, your time division multiplexing has become more widespread in recent years, right? Now here each sender is given the entire position of the whole bandwidth of the channel for a fixed duration of time, right? So instead of dividing the frequencies, what you are doing, you are dividing the time, and then you say that okay, this particular sender will have the complete bandwidth of the channel for a fixed duration of time, right? So you are basically dividing the time slots among various senders and for their particular or fixed time slots. That means the time slot that has been assigned to a particular sender for transmitting the data, for that particular time slot, the sender will have the complete bandwidth of the channel, right? So it will have the complete or entire position of the bandwidth of the channel. Now after the sender's time has passed out, right? So after the time has passed out, or after that particular time slot for this sender is over, the control is passed on to the other sender in queue, and so on, right? And this process continues in a round robin fashion or a round robin basis. Now what is round robin basis? Basically in round robin basis, you choose elements out of a group of elements. You choose elements in such a way that you start from the top to the bottom or from the first element to the last element. That is, you start from the first element or the topmost element, you go on to the second element, third element, till the last element, and then you again move on to the first element and then second element and till the last element, and then again to the top or first element. So this continues. So this particular basis of selecting elements is known as the round robin basis. So here in time division multiplexing also, all the senders are selected on a round robin basis, wherein each sender is selected for a particular duration of time. It transmits the data for that duration of time. Now for such a small duration of time, the sender may not be able to send the entire data that it wishes to send. So obviously it has to wait again for its turn, which will come in a round robin basis. So when its turn comes again, then it will send the remaining data. Then again it will wait for its turn, and then it will again send the remaining data, and so on till it sends the entire data that it wants to send. So this is how these senders transmit data in case of time division multiplexing. Now if I tell you about an example of time division multiplexing, it is something very common to us, that is television broadcast. We all watch television and we all are aware about television broadcast. So generally in a television serial, if a serial is being broadcast and if there are 15 minutes which have been allocated to a TV serial or a television serial, so out of those 15 minutes, usually 10 minutes are for the serial and 5 minutes are for the advertisement, right? So this 10 minutes or these 10 minutes which are allocated to the serial, these are completely for the serial. So this particular time slot of 10 minutes is completely allotted to the serial, and then the 5 minutes which are allotted to the advertisement, this particular time slot of 5 minutes is completely allotted to the advertisement. So for 10 minutes the serial completely utilizes the bandwidth of the channel. The whole position is for the serial, and for these 5 minutes the advertisement utilizes the complete bandwidth of the channel. That is, these 5 minutes are only and exclusively for the advertisement. So this is a perfect example of time division multiplexing. Now basically there are two types of time division multiplexing: synchronous time division multiplexing and statistical time division multiplexing. Okay, so what is synchronous time division multiplexing? Basically, in synchronous time division multiplexing, the time slots are given in a synchronous manner. That means time slots are pre-assigned or assigned in advance to the senders, right? So, if these time slots are pre-assigned or assigned in advance to the senders, that means irrespective of the fact whether the sender has something to send or not, these time slots will be allotted to the senders. And if in case a sender does not have any data to send during its allotted time slot, then that time slot gets wasted and the bandwidth of the channel for that particular time slot is not utilized, right? So this is the concept of synchronous time division multiplexing. Now coming on to statistical time division multiplexing, which is also known as asynchronous time division multiplexing. Now we just saw that in case of synchronous TDM, the bandwidth gets underutilized, the time gets wasted in case a sender does not have any data to transmit. So this is overcome with the help of statistical or asynchronous TDM. Now in statistical TDM, what you do is that if in case a specific sender or terminal has no data or information to send, right, for its time slot. Say for example, the time slot that was allotted to a particular sender, that time slot has come and the turn for that particular sender has come, and so in its turn for that particular time slot, the sender has nothing to send. What it will do? It will share that time slot with some other sender who has data to send and is willing to send the data. So your time does not get wasted and the bandwidth of the channel does not get underutilized. Right? So the sender says, I do not have anything to send for my particular time slot. What I'll do is that I'll share or pass on my time to some other sender, and that sender, if it has a data to transmit, will transmit the data during that particular time slot. So basically the resource or the bandwidth does not get wasted, right? So these slots here are allotted dynamically. Dynamically means as and when required. That means if a sender during its time slot has some data to send, it will be using that time slot, and if it does not have anything to send, it will share its time slot with some other sender. So the time slots are basically allotted dynamically depending on what? Depending upon two factors. One is the speed of the source, right? If the source is at a fast speed and it transmits data before its time slot has finished, it can pass on that particular time slot to some other sender. Similarly, it also depends upon the ready state. That means if the source is not ready at all to send the data, so in that case, you will not wait for that particular time slot. What you will do rather, you will share or pass on that time slot to the some other sender who has data to be sent, right? So this is the concept of statistical or asynchronous TDM. So basically, in a summary we can say, or in a gist we can say, that time division multiplexing is used when the data transmission rate of media is greater than that of the source. Media means the channel through which we are transmitting the data. So when the data transmission rate of the channel is greater than that of the sender, in such scenarios, time division multiplexing is used, right? And each sender or each signal is allotted a definite amount of time. That is a fixed amount of time. And these time slots are so small that all the transmissions appear to be parallel. That you don't realize that these time slots are being divided because it is in a fraction of seconds. So you don't actually realize that you're waiting for a particular amount of time. It happens so quickly. The switching is so fast, and for that reason, all the transmissions appear to be parallel. So this is the concept of time division multiplexing.